All right, today we're going to pull back the curtain on something that powers pretty much the entire internet, databases. And we're going to be looking at one of the most powerful and popular ones out there, PostgreSQL. Let's dive in.
Have you ever stopped to wonder how a site like Facebook or eBay actually works? I mean, think about it. It knows your name, who your friends are, what you liked 5 years ago. eBay knows every single item for sale, its price, its seller, and that thing you left in your shopping cart last week. How on earth do they keep track of all that information for millions of people?
Well, the secret behind all that magic, it really just boils down to one simple concept: a database. It is the invisible engine that makes pretty much everything you do online possible.
So what is a database really? Well, at its heart, it's just a system to store, change, and get data back out again. The absolute best way to picture it is like a giant digital filing cabinet. But it's not a messy one. It's a perfectly, obsessively organized one where every single piece of information has a precise home. Okay, so we have this giant digital filing cabinet. But what does that organization actually look like? That's where the structure comes in, and we're going to explore it using our tool for today, PostgreSQL.
Now, PostgreSQL is what's called a relational database. I know, that sounds super technical, right? But stick with me, the idea is actually incredibly simple. It just means it organizes data into tables. And you can just think of these tables as individual spreadsheets. The relational part just means you can link these spreadsheets together. So you could have one for customers and another for orders, and you can link them up.
And here's what one of those tables looks like when it's just an empty shell. Before you can put any data in, you have to define the structure. You create these columns, like ID, first name, last name, and so on. It's like labeling the folders in your cabinet before you put any papers in. Once you have that structure, then you can start adding the actual data, which we call rows.
So why are we focusing on PostgreSQL? I mean, there are lots of databases out there. Well, this one's a real powerhouse. It's super fast, it's famous for being reliable, it's been around for over 30 years, and here's the kicker. It's completely open source. That means it's free. You can see why it's a massive favorite for startups that need all that power without the huge price tag.
Okay, our filing cabinet is set up, it's organized, but how do we actually talk to it? How do we ask it to put a new file in or find an old one for us? To do that, we need to learn its language. And that language is called SQL, often pronounced SQL. Now, I know what you might be thinking when you hear programming language, but honestly, the source material hits the nail on the head here. SQL is actually designed to be very easy to learn. It reads a lot like plain English.
Don't believe me? Just look at this. On the left, you've got the actual SQL command. Looks a bit technical, sure. But look at the right. That's all it's really saying. Show me everyone who is female. You literally select what you want, say where it's from, and give it a where condition. See? It's basically just asking a question.
All right, now that we know the basic language, let's put it to work. We're going to look at the two most fundamental things you can do with it, putting data in and getting data out.
So, first things first, we need to put some files into our cabinet, right? In SQL, we do this with the insert command. And yeah, it does exactly what it says on the tin. We are inserting a new piece of information, a new row, into one of our tables.
Let's imagine our person table already has a couple of entries. You can see them here, 2 different people, already filed away nice and neat in our system.
And now we run our insert command. And just like that, a brand new row gets added to the table. We've just added a new person to our database. It really is that straightforward.
Okay, putting data in is great, but the real magic of a database is getting the right data back out. How do we find that one specific file in a cabinet with thousands, maybe millions of files? Well, we use that select command again, but we add a magic filter to it called a where clause.
So let's scale up. Imagine our table isn't just 3 people anymore. Let's say it has 1,000 people from all over the globe. Trying to find someone specific by just scrolling through that? No way. That would be a nightmare. But with one simple where filter, we can just ask the database, hey, can you just show me the people where the country of birth is Poland? And bam, it zips through all 1,000 records in a flash and hands us back just the 7 that we asked for. Think about how incredibly powerful and efficient that is. Finding specific people is cool, but that's really just scratching the surface. The true power of all this is when you start asking bigger, more interesting questions of your data. For instance, what if we wanted to know not just who is from Poland, but how many people we have from every single country in our dataset? That's a totally different kind of question, right? It's not about finding a person. It's about finding a pattern. You'd think that requires some super complicated command, but it doesn't.
It's just 3 logical steps. First, you tell it to select the country and to count the people. Then you tell it where to look from the person table. And here's the key. You tell it to group the results by country. So it basically puts everyone from China in one pile, everyone from Brazil in another, and then just counts each pile.
And what you get back is this, an incredible insight. With that one simple question, we can instantly see a story in the data. Look at that. We can see right away that China is the most represented country, followed by Indonesia, and then Brazil. We just learned something new from that massive table of names.
And that's really the whole point. We started with a huge table of 1,000 people, we asked one smart question, and we got back this one specific powerful number, 182 people from China. That's a precise, actionable insight that took milliseconds to find.
So we've gone from organizing information in a digital cabinet to asking it simple questions, and then all the way to summarizing that data in powerful ways. This is the fundamental skill that unlocks the stories hidden in data. So it really just leaves one last question. Now that you know the language, what questions would you ask the world's data?